Hey guys, this is Michael from Conquer Chemistry. In this video, we'll be going over several Henry's Law problems together. But before we look at the problem, let's first talk about what Henry's Law is and the equation that's associated with it. So Henry's Law states that the solubility of gas is directly proportional to the partial pressure of the gas. That means that if you were to increase the pressure of the gas, then that will increase the amount of gas that's dissolved. So we can say that that will increase the concentration of the gas. And then likewise, if you were to decrease the pressure of the gas, then that would decrease the concentration of that gas. It will decrease the amount of gas that's dissolved in the solvent. The equation that's associated with Henry's law is this one. C equals K times P. C is the concentration of the dissolved gas, and that's just the molarity, which is the moles over the liters. K sometimes is also written as Kh. That's the Henry's constant, and that's a constant that's unique for every gas. And the units for that it's molarity per ATM. But in different textbooks you might see it in different units, but this is the most common unit that's taught in the majority of AP classes and high school classes and college classes. And then P is the partial pressure of the gas, and that is measured typically in ATM. So here's the question. The solubility of nitrogen in water is this. So this is the molarity, is the concentration of the nitrogen gas that's dissolved in water at 0 degrees Celsius when the nitrogen pressure over the water is this. So now here you're given the pressure, and it's asking to calculate the Henry's constant for N2. So since we're dealing with Henry's law, let's start with the equation. It gives us the molarity. So we know that the molarity is 8.21 times 10 to the negative 4 moles per liter, which is the same thing as molar. Our goal is to solve for the Henry's law constant. So we don't know what K is, or KH. And it also tells us the pressure that it is 0.790 ATM. So to solve for KH, all we have to do is just divide both sides by 0.790. So we'll take this number and then divide it by the pressure, and that'll leave us with the Henry's law constant, which is equal to 0.00104 molar divided by 8 ATM. So now that we know the Henry's law constant, we can answer the second part of the question. So the second part of the question is asking us to calculate the solubility N2 when the partial pressure above water is now 1.1 ATM. So previously it was 0.79 and now it's increased to 1.1. Well, we know that if we increase the pressure, that should cause the concentration to go up. So that means that the amount of N2 dissolved should be higher than 8.21 times 10 to the negative 4. And to solve for the new concentration, all we have to do is take the KH that we previously calculated, multiplied by the new pressure. So the KH is 0.00104 molar per ATM. Then we multiply by the number of the new partial pressure, 1.10 ATM. And then that way the ATMs cancel out. And we'll be left with 0.00114 molar. That's the new concentration. You see that the new concentration, if we turn this in scientific notation, we move the decimal point over 3 times, so 1.14 times 10 to the negative 3 molar. And you can see that the new concentration is greater than the original concentration because we have increased the pressure. Great. Let's take a look at the second problem, a slightly different one. This question asks us, what mass in grams of carbon dioxide is dissolved in 500 milliliters of soda that's under a pressure of 3.8 atm at 25 degrees Celsius? And it gives us the Henry's constant, 3.34 times 10 to the negative 2 molar per atm. Well, let's again start with the Henry's law and think about what we already have. So we're given the Henry's constant over here. We're also given the partial pressure right here. So we multiply these two, then we can get the concentration, the molarity. And from molarity, we can figure out the number of the grams. Let's start by solving for the molarity. So the molarity C, we'll just call it molarity. The molarity is going to equal the K times the P. So the K is 3.34 times 10 to the negative 2 molar per ATM multiplied by the number of ATM, which is 3.80 ATM. Then the ATMs cancel out, so we're left with just molarity. 3.34 times 10 to negative 2 times 3.8. That gives us 0.127 molar of the CO2. So we know that molarity is equal to the moles divided by the liters. So let's just write that. We have the moles of CO2 divided by the liters of the solvent. It tells us the milliliter is the solvent is 500 milliliters. So to get this into liters, we just have to divide this by 1,000, and then that'll give us 0.500 liters. So that's what we can plug in for the liters of the solvent, 0.500 liters. Now we can multiply both sides by 0.500 to get the moles of CO2. So the moles of CO2 will be equal to 0.127 molar times 0.500 liters, which gives you 0.0635 moles of CO2. Now that we have the moles, we can just multiply by the molar mass to get the grams. So we'll take the 0.0635 moles of CO2 that we previously got, multiply by the molar mass. So 1 mole of CO, but actually we want to put the 1 mole of CO2 on the bottom so you can count out the moles. And then the molar mass of CO2 is approximately 44.01 grams of CO2. And then when we do that, you can see that the moles of CO2 cancels out, leaving us with just the grams of CO2. Which comes out to be 2.79 grams of CO2, which is the final answer. So there you have it. You have three different type of problems that's related to Henry's law. This when you're reading a question and it mentions the pressure and the solubility and the amount of gas present, then you should be thinking this is a Henry's law problem. Start with the equation and then think about what's given and what you're solving for.
If you want to learn how to ace chemistry, if you want to learn what's the best way to study for this class, if you want to learn some neat tricks and tips to take into your exam and do better on them, then you should head over to my website and get this free guide, 12 Secrets to Acing Chemistry. You can head over to www.conquerchemistry.com/chemsecrets. I'm going to include a link in the description below. Check it out. I think it's really going to help you and you're going to like it. Until next time, keep working hard and continue the good work.